we are going to combine our two equations. Okay, so what does that mean? I'm going to kind of skip what's written out because if I just talk at you, you may not absorb as much. So let me do an example where you are not writing anything, you don't have a writing utensil in your hand, and you're just observing. Okay? So linear combination, first of all, we want it to be in this form, ax plus by equals c. So if it's not already there, which I think most of them will be set up nicely for you, but if it's not, you want to get it so that both of your variables are to one side. Okay? And then what we're going to do is we're going to write one equation on top of the other. So see it right here, it says arrange the equation so the x's and y's line up. So here's my first equation. 4x plus 3y equals 16. Here's my second equation. 2x subtract 3y equals 8. Now this particular equation, it would be absolutely silly not to use this method because it's actually it's going to work out perfectly here. It's not always going to be so nice right away, and we'll see that in a second. But we've lined up, so we basically created columns here. Do you see what I mean? So here are my x's, and again, you're not writing this, you're just absorbing knowledge. Just absorbing it like a sponge. Okay? So here are my x's, here are y's, and here are just constant numbers. It says, notice that the coefficients for y's are already opposites. So this is our whole goal, is that once it's lined up, we want opposites. So what's an opposite? -3 and +3, like I have right here. 2 and -2, 4 and -4, whatever. You want opposites, okay? Now, what we're going to do is add the equations, just like it sounds, linear combination. We're going to combine them. So we're just going to add and get a brand new equation here. Now, you don't add until you have opposites. This one already has opposites, so we're all set to go. So adding 4x and 2x give me, 6x. 3 and -3 give me, not writing, just absorbing, like a sponge.
I'm
3 and -3 give me 0. Yeah, sounds weird. You were scared to say it. That's exactly why we want opposites. If I have +3y and -3y, I have no more y's. It's just like if you had $3 and you went to the school store and spent it, you don't have any dollars left. Okay, you don't have one y, common error, to just put y there. No, 0, gone, see ya. That's why we want opposites, because then look at what happens. 16 and 8 would give me 24. Hey, look, I don't have y anymore. I can just go ahead and solve for x. Okay, that's the beauty of linear combination. You combine it, and now we're all set to go. 6x equals 24, so how do I get just x? Divide by 6. And x equals 4. Okay? So I'm halfway there. I know what x is. So now it says substitute x equals 4 into one of the equations and solve for y. It does not matter which equation you choose. Would you like to use equation 1 or equation 2?
2.
Sure. So 2 says 2x minus 3y equals 8. So I'm going back to my original equations. Doesn't matter which one you choose. X is 4. So I substitute it in. And now I'll solve for y. What's 2 times 4? 8. 8 subtract 3y equals 8. To solve for y, subtract 8. And what happens? -3y equals 0. So y equals 0, because when I divide by -3, it's still going to be 0. So it says, check that 4, 0 is a solution by substituting 4 in for x and 0 in for y in both equations. Before we do that, I will give you time to write now that you have absorbed. Once you're done, you can go ahead and check it. Here's equation 1. 4x plus 3y equals 16. Equation 2. 2x minus 3y equals 8.